All right, guys, this is the video on the worksheet writing proportional equations from a graph. I'm doing this one at my house, so it's going to look a little different than they normally do. Might even sound a little different. Okay, so I just wanted to give you guys a few examples on how to do these ones before you do them on your own. Okay, so we want to know how to write an equation when we're given just a graph. Now, we practiced this in one of our, with your partners after a unit, and I can't remember if it was I think it was 2.2, and I'm not quite sure some of you guys got it, and it's kind of thing is on the quiz, so I want you guys to understand it. So the first thing that we need to do is we need to pay attention to what's being compared on the X and the Y axis, okay? So in this case, the hiking distance one, we're comparing distance to time, and that distance is in miles and that time is in hours. That's what that H stands for. So if you remember back from when we were talking about proportional tables and how to tell if they were proportional, what I told you was that they would have a constant rate, and what you needed to do was take your Y value and divide it by your X value, and that would tell you if they were constant, if they constantly reduced to the same ratio, then they were proportional because they had a constant rate of change. So it's the same kind of thing when you're doing it from a graph, because the first thing you need to do is figure out what my rate of change is, or my unit rate, or what constant rate of change. And in order to do that, I need to divide my Y value by my corresponding X value. Now, it's a little different on a graph than it is from a table, because we're not just given those numbers. Here we have to actually find a point on the line and then figure out what its ordered pair is, and then go from there when we're trying to figure out the unit rate. So you can see that this graph actually has a couple different points already on it. I know that this is proportional because it goes through the origin and it's a straight linear line. And so I know that it's proportional, so I know that it has a constant rate of change. I just need to figure out what that constant rate of change is. So you can pick any of these points or any of the other points really, but you want to pick one that's, that hits at a corner in the back of the grid back there. So I'm just going to pick this one right here. Now remember, my ordered pairs are always in the form of X comma Y. And this is my X axis and this is my Y axis. So I'm going to go over to my X first, and since I'm using this point, it's 10. And then my Y is 12. Okay? So then what I'm going to do is I'm going to take my Y value, which is my 12, and divide it by my X value, which is my 10. Okay, when I do that, oh, I should get a calculator. Hold on one second. All right, I don't have with me at home the ones that we have in class, so you'll just have to kind of deal with this big one that I've got. So now what I'm going to do is, remember, in order to find unit rate, I need to get this to a 1. So I'm going to divide this one by 10, which means I have to divide this one by 10. I shouldn't have written that equal sign so close. Right there. Okay, then I'm going to find out what that equals. 10 divided by 10 is 1, which is perfect because that's what I want. And 12 divided by 10 gives me 1.2. And I'm just going to write that as a decimal. It doesn't have to be a whole number. It's fine. Okay. So my rate of change, or my unit rate, or my constant rate of change is right here. Now in this case, I don't really care about you having labels because we're just going to write the equation and we don't have to have the labels in the equation. When we come over here though, we need to talk about what this means. Okay. So my rate of change, and I don't have to write the 1 under it. So I'm just going to write 1.2. Okay, and then remember, my Y-intercept is where my line intersects the Y-axis at. So if this is my Y-axis right here, and this is my Y right, let's see, do I have another highlighter in here? Probably not. Well, anyway, we'll just use it. Oh yeah, I have this bright green one right here. And this is my line. Wherever they intersect is that Y-axis. Well, if you look, because it's proportional, it should be intersecting right there at the point 0, 0. So my Y-intercept is 0. Okay, now I'm going to write my equation. Remember, the equations, when they're proportional, and these are all proportional because that's what we're talking about today, is Y equals mx. So technically, I don't even need the Y-intercept if it's 0. Okay, so I already have the Y equals here. My m, I said, is 1.2, and then I just add the x. Now, technically, you could write plus 0, but plus adding 0 to anything doesn't change it in any way, so you don't have to write plus 0 there. Okay, so there's your equation. Now, over here where it says, in words, what do the following represent? So now what we want to know is, what does this 1.2 over 1 mean? Because that's my m, right? Those are the same thing. Now remember, this is my y value and this is my x value. So all I have to do is look at my y axis and figure out what it's labeled. Look at my x axis, figure out what it's labeled. And then I should be able to easily figure out what it means. So this 1.2 is the y, so it's miles. So it means 1.2 miles. And then this is time in hours, and so that 1 is hours. So you could say 1.2 miles per hour. You could say 1.2 miles every hour, each hour. It doesn't matter which word you use there. Per is the more common one, but you can use the word each, every, per. Remember, those are those key words that we're always looking for when we're talking about unit rate or rate of change. Okay, so my rate of change means that whoever this is hiking this, they're hiking 1.2 miles every hour, or each hour, or per hour. Okay, so that's what that means. So now let's talk about what this specific point means on the graph. So this is the point that we actually chose, which is good. So this is my x. Remember, this is an ordered pair, so it's x comma y. So now I'm going to do the same thing I just did here, where I just matched the labels of the axis to the variable. Okay. So this 10 is represented by the x, which means I need to go to my x-axis. So this is 10 hours. So 10 hours. And then the 12 is my y. My y is in miles. So 10 hours equals 12 miles hiked. Or, and you could rephrase this. You could say 12 miles in 10 hours. That would work too. You could switch them around if you wanted. Just make sure that you don't do it until after you figure out the labels, okay? So that means that in 10 hours, I'm going to be able to hike 12 miles, or this person hiked 12 miles. Something like that to let me know that you understand what it is that we're talking about. Because these all have meaning, you guys. It's not just numbers. They have a meaning, especially when we have a graph here to tell us what these x's and y's mean. Okay, so I'm actually going to have you flip it over, and there was one that I thought, ooh, I better do that one with them. Oh, I wanted to do one that had a good 1. Okay, let's actually do, let's do this one on the back, the plant growth one. And the reason why I want to do this one is there's a specific reason why I want to do this one. So, this is talking about a plant's growth, and this is in centimeters and in months down here. So I need to find my constant rate of change, or my unit rate, or my rate of change. Remember, they're all the same. Now, this one, compared to the one that we just did, if you look at this one right here, this one doesn't even have like a 1 down here on the x-axis. This is like 2.5 and 5 and 7.5 and 10. But this one, the plant growth one, make sure that that's like not wanting to focus, is it? There we go. This one actually has a 1 for the x. Now remember, when I'm trying to find my unit rate, I want this in the form of x over, or y over x, and I want a 1 as an x. That's my unit rate. Instead of just a rate, it's a unit rate. So if I can figure out the point where x is equal to 1, I won't have to simplify anything. I'll already have my unit rate. Okay, so this one has a nice little point on where x equals 1, and its corresponding y is 30. So now I have this as a unit rate. I don't have to do what I had to do on the other side by dividing by 10. I don't have to do that on this one. So that's one thing I wanted to show you. If you can find a nice even point, and by nice and even, I mean, you know, one that falls on a corner so that they're easy to see what the values are, use it, because then you don't have to simplify anything. You've already got a unit rate. So then I can just put that 30 down here, because remember, I don't have to put the 1 under it when I'm writing that if I don't need to. Okay, my y-intercept, again, this is a proportional graph. It crosses the y-axis at 0, so my y-intercept is 0. My equation, remember, is just my rate of change, or my m, times my x. Okay, this is the easy part. The trickier part is understanding what they mean. So let's talk about that part. So again, this is my Y, this is my X. So my Y is represented by centimeters and my X is represented by months. So what this is telling me is that it grows 30 centimeters each month, per month, every month, okay? Anything like that. 30 centimeters every month, each month. Okay, now the 0.260 should have some kind of reference. It should have the same thing. It just means it just has more centimeters and more months. So remember, this is X, this is Y. So my X is my months, my Y is my centimeters. So what this is telling, this 0.260 is telling me that in 2 months, the plant grew 60 centimeters. Okay, or 60 centimeters in 2 months. You don't have to write quite the long sentence that I did. Something that lets me know you know that the 2 represents months and the 60 represents the centimeters in this case. All right, guys, so you have 3 more on this side and 3 more on this side to finish. Then when you're done, again, just like you did with the first worksheet, check it with the sub, with the key that the sub has. Make sure you understand what you're doing. And then the next and last thing that you need to get done before class ends is you have like a 5-question or 6-question quiz. Actually, I think it's like 10 questions, sorry. A 10-question quiz that you need to get done before you leave class today. So it should be next in line on the Schoology folder. Then if you finish that, you can do Alex after that. All right, thanks guys. Have a great day.